Hey guys, it's Mr. DeFelice. Let's look at example 1 from day 1 of your Quadratic Unit 2 packet. We're going to look at how to graph this quadratic function using vertex form and then using the axis of symmetry to kind of make our lives a little bit easier. So you have to remember, vertex form is when you're given an equation in this form. And we can use the vertex to graph and find the vertex using these coordinates. And then the axis of symmetry is whatever your x value is in your vertex. So let's look at this example. Remember, in these equations, inside the parentheses you do the opposite. So the vertex is going to be located at, if it's h comma k, it's going to be located at -3 comma 4. So I'm going to plot my point at -3 comma 4. Based on what we learned in class, our axis of symmetry is that x value, so x equals -3. So I can draw a dotted line through -3 to show that that's the axis of symmetry. And what that means is that I can reflect the image on the left-hand side over this line, and it should match up with what's on the right-hand side. So I'm going to write down the equation as well, x equals -3. Alright, so how can I find some points to plug in on this graph? Well, I'm going to make a table. We'll call it x and f of x. Remember, f of x is just your y values. Let's do 5 points. So I'm in the middle, I'm going to put the vertex. I know where the vertex is, and I want to get points that are around it. I want to go 2 points to the right and 2 points to the left. So I'll plug in -4, -5, and -2, and -1. This way I'll be able to get a nice solid graph of our quadratic. So if I plug in -5 into our function, f of -5 equals -2 times -5 plus 3 squared plus 4. Keep going. -5 and 3 is -2 squared plus 4. Remember, you do orders of operations. Exponents come first before multiplying. So I did my exponent there. 2 negatives makes a positive. Then I can multiply, and now I can add. So -8 plus 4 is -4. So my first coordinate, yes, -4. So my first coordinate is located at -5, comma -4. With the idea of symmetry, since this point is 2 spaces away from the line of symmetry, I'm expecting a reflection of it 2 spaces to the right as well. So if I plugged in -1 into this formula, or this equation, you would get the same answer of -4. That's the whole option, or the idea with the symmetrical nature of the graph. Now I can do the same thing for f of -4, plug it in, and see what comes out. So -2 times -1 squared plus 4. -1 squared is +1, because -1 times -1 is +1. That's -2 plus 4, which gives me +2. So when I plug in -4, I get out 2. So if I go to -4, I can put 2. Symmetrical nature, this is 1 space away from the line of symmetry, so over on this side it'll also be 1 space away. And then there's a nice solid representation of my equation, and now I can graph it. In some ways you can check that you're doing this right. Continue using the rest of the table and just plug in these values to make sure. Use your calculator, plug it in and make sure. Or also looking at the equation, I know it says -2 in the beginning, so this means it has to be a reflection of the graph, and normally the graph is facing up. So now I've reflected it over the x-axis, so you can see that in the graph that we drew. Okay, tomorrow I'll have the notes for you on examples 2, 3, 4, and 5 for day 1.